this is our introduction to exercise 5.5 on composite functions. The whole idea of a composite function is when we combine multiple functions at a time. Composite, of course, meaning more so like combination. Let's look at an example. Like in this case, we've got f of x equals to 3x plus 2 and g of x equals to x squared. We've been given a composition of h of x. H of x is quite commonly used. Page 19. Where h of x equals to g, and we're going to read it as g of f of x. G of f of x. So whatever we put in for x, the input of x changes the output of f of x, which then becomes the input for g of x, which then gives us an output. That's the long way of going about it. We can rewrite this, instead of saying g of f of x, we can rewrite it as g dot, or o, f of x, right? Speaking of dot, please make sure you don't write g dot f x like that. Of course, that means g times f of x. It should be an open dot, so it ends up being g o f of x. Right? Something to note, g of f of x generally does not equal to f of g of x. Of course, instinctively, g of f of x is when f of x is on the inside. And so f of g of x is when g of x is on the inside. Okay? But generally speaking, unless they're the exact same equation, they don't equal the same thing. Okay? So if I was to find g of f of x, all I do is I substitute x with whatever function was given for f of x. In this case, h of x equals to, I'm going to substitute 3x plus 2 into my g of x. So it becomes bracket 3x plus 2 squared. Any questions? Okay, before we move on to the next part, I'm going to get you to copy down two formulas for me. Or not formulas, sorry, things of note. The domain of f of g equals to the domain of f. That's the first one. The second one is f of g, for f of g I should say, the range of g is a subset of the domain of f. I really recommend you write this down. For f of g, the range of g is a subset of the domain of f. This next one you can copy down if you'd like. It's just the opposite version of that for our g of f. So g of f is the range of f as a subset of the domain of g. We'll apply that in a second. Okay, the first formula basically says that once you've found your f of g, the domain of that is restricted by the domain of f. Pretty straightforward. The second point of note, in order for f of g to exist, the range of our function of g must be a subset of the domain of f. Our range of g must be within what we're providing for the domain of f. Alternatively, the range of f must be within the domain of g. For our g of f, sorry. In example 6, we're presented with, again, to find f of g and g of f, we're presented with f of x and g of x. What we're going to do is we're going to find the domain of each. I'll leave the range, actually, no, yeah, we'll do the range. But we're going to focus on the domain component, right? Because the domain is what's really important here. First, we identify whether it even exists or not, and then we do it. Because we're finding both f of g and g of f, what I'm going to do is I'm going to write out a table that shows us the domain and the range of each. So copy down this section where I'm going to write down the f, the g, our domain, and our range. The domain of 2x minus 1, pretty straightforward. That's all real values. The range of it, again, pretty straightforward. It's just a linear equation. Domain and range is all real values. The domain of our function of g, right, 3x squared, again, all real values. Is the range of that also all real values? Of course not. Thank you very much. It's going to be from either, you can write it either as all real positive values in unison with 0. Oops. Or you can write it as from 0 to infinity. Either one's fine. It's just more so notation. So let's look at focusing on f of g. For f of g to exist, and I'm going to refer back to my formula from above, the range of g must be within or must be a subset of the domain of f. In this case, the range of g is limited from 0 to infinity. The domain of f is limited as all real values, so therefore it is a subset, therefore it does exist. So I'm going to put my function in. I'm going to put my g of x into my f of x. My g of x is 3x squared. I'm going to put that in, so I get 2 bracket 3x squared bracket minus 1, which equals 6x squared minus 1. Now, we know it's a parabola, right? But our domain of our new function is going to just equal, just like I wrote above, is going to just equal the domain of f. Yeah? So, I'm going to write the domain which equals to all real values. And based on the idea that because it's a parabola, we know that the range is going to go from -1 to infinity. Let's do an alternate one. Let's try doing our g of f. It is going to look different. For g of f, we're going to substitute, let's find out if it even exists. So, for g of f, the range of f must be a subset of the domain of g. So the range of f in this case is all real values. The domain of g is again all real values. Great, I'm happy it's a subset, therefore it does exist. I substitute my values in, and I get 3 bracket 2x minus 1 squared, which simplifies to 12x squared minus 12x plus 3. The domain of this function is going to be again all real values, right? Because beforehand for f of g, the domain is f. So for g of f, the domain is just a domain of g. And the range, based on what we know of this kind of function, is just going to be 0 to infinity. What I'm going to do is I'm going to show you the second example. I won't go through all of it, but I'll show you what it looks like when it doesn't exist. So, for our second example, we've got x squared minus 1 and square root of x. Obviously, we've got two functions now that are very different and are very clearly defined by a domain. So, I'm going to write my table up again, f, g, I'm going to write domain and my range up here. There we go. I know that the domain of my function of f, in this case x squared minus 1, x could be all real values, but the range of it, of course, isn't. It's going to go from -1 to infinity. The domain of g of x is not all real values. Because it's a square root function, I know that x can't be a negative number. Therefore, from 0 to infinity. And instinctively, 0 to infinity for our range as well. In order for f of g to exist, the range of g must be a subset of domain of f. Now the range of g is between 0 to infinity. The domain of f is all real values. Yeah? Is that a subset of domain of f? Is 0 to infinity fitting within our all real values? Yeah, okay. What about g of f? For g of f, the range of f must be a subset of the domain of g. Now I should write exists here. Here we go. For g of f, right, our range of f is going to be our -1 to infinity. Our domain of g is going to be 0 to infinity. -1 to infinity does not fit inside 0 to infinity. Therefore, it does not exist. And we write it in mathematical notation as the range of f is not a subset. So we draw a subset sign with the slash in the middle of the domain of g. And therefore, g of f does not exist. Any questions? Okay.